It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about limits of transcendental functions. Okay, this time we are going to do our tabular approach for this one. And always remember that every limit in there, we can solve that one out using our tabular approach. So using the tabular approach here for this particular function, we have limit of e to the power 8x minus 1 over x as your x approaches 0. Although we can get that one using the special case there, but again, every limit problem there can be solved using tabular approach. So using tabular approach, we're getting a number from the left of 0. We're examining the approach value on y from the left of 0. So left of 0, we can simply get an x value here as negative 1. And our f of x here is equal to, once you try to input your function on the calculator, you can set that one up on a degrees mode. So we have here e to the power of 8 times negative 1 minus 1 over negative 1. So try to input that one on the calculator. You can look for e to the power of x function, or you can simply have it for those who got a very nice calculator out there. So you have actually that particular function. Okay, so the result here after inputting that one on a calculator, we have that as 0.9997. So you can do 3 digits in there after the decimal point, but I'm showing this one here because if I'm choosing 3 digits right after decimal point, this will become a 1. So anyways, moving on, we have negative 0.5 will be the next one. We're moving closer to 0. So from the negative 1. So we have negative 0.5. Inputting that one on the calculator, we have e to the power of 8 times negative 0.5 minus 1 over negative 0.5. That will be equal to 1.963. Next value, moving closer to our 0, we have negative 0.1. Inputting the values on the calculator, we have e to the power of 8 times negative 0.1 minus 1 over negative 0.1. This is equal to 5.507. Next, we have negative 0.01, in which once you input that one on the calculator, you will have that there as 7.688. And again, if you cannot see a pattern there, you can go ahead and look for more or add more numbers that will be moving closer to 0. So we can have it as negative 0.001, in which the value for that one is 7.968. And then if you do not see again a pattern in there, you can just simply add more zeros. So negative 0.0001, which is equal to 7.9968, in which that is very close to an 8. So this one here is approaching to a value which is 8 on y once we try to approach 0 from the left side. So might be our limit there, but we cannot be so sure on that one. We need to check from the right of 0. So we are going to get our x value from the right of 0. Let me change my ink because that might not be that clear. So our x, our f of x here, our x, we can have it as 1. And then inputting that one on the calculator, we have that as 2,979.958. And then we move closer to 0. We have a 0.5 here. Then this will be 107.1963. And then we have 0.1. This is equivalent to 12.255. And then we have a 0.01. This is equivalent to 8.839. I mean 29. And then we move closer because we cannot see a pattern in there. So we have 0.001. That might be closer to 0 again. So we have our 8.032. We're trying to check if that will be approaching to 8 here. We have 0.0001 again, another number closer to 0. We have that one as 8.003. So no matter how many zeros you're adding there, that will be moving closer to the value on y, which is an 8. So which means that the answer for this one is an 8. That's the limit of that one. Let's now move on to another example. We have limit 1 of 1 minus cosine 2x over x as your x approaches a 0. Using tabular approach, we can get values from the left of 0. We can have that one as a negative 1. Inputting that one on the calculator, again, reminders, you have to set that one in a rad mode because we're dealing with a trigonometric function here. So we can simply input 1 minus cosine times 2 times negative 1 on the calculator over negative 1. And that will be equal to on f of x as negative 1.416. And then approaching to 0, we can move to negative 0.5. And we have that one equivalent to negative 0.919. We cannot see any pattern at all there, so we move closer. Negative 0.1. This will be equivalent to negative 0.199. And then we try to add more, negative 0.01. This is equal to negative 0.02. And then since we cannot tell the pattern, so we can have it negative 0.001, then we have that one equal to negative 0.002. So if you try moving closer to a 0, this will also be moving closer to a 0 also. So let's now go to the right. So we have x and then f of x. So from the right, we can get 1. Inputting that one on the calculator, we have that as 1.416. And then moving closer, we have 0.5. That will be equivalent to 0.919 on the calculator. And then we have 0.1. That is equal to a 0.199. And then 0.01, which is equal to a 0.02. Next, we have 0.001, which is equal to a 0.002. So right from here, we have now a pattern. This is approaching to a 0 as well. So the limit of this one is a 0. So that is how you are going to find the transcendental function using tabular approach. So once again, this is your teacher Jenny saying, practice and practice, and that will be leading to or approaching to perfection one day.